So is this a function? Not a function. There's a relationship, but that relationship is not a function. Now, if I made this graph look like this and then change it to a straight line, sort of looks like clock hands, is this a function? And the answer is yes. It would pass the vertical line test. No matter where I draw a line vertically, it will pass through that graph only one time. So yes, it's a function. Let's do a little bit of practice. Looking inside of our booklet that we were working on, determining whether each relation is a function. Take a minute, pause this, do it, and then come back and I'll go through the solutions. Here are the solutions. The answer to this one is not a function. And the reason why it's not a function is there are negative ones that are repeated. For this one, it is a function. Okay? It passes the vertical line test. No matter where I draw a vertical line will cross only once through this graph, anywhere. For number 3, the negative 2's are repeating, so it's not a function. And for the last one, I have unique x values, so it is a function. Now, going to this other example over here, justifying function or not a function. Looking at this graph, I see 1, 2, 3 points. So it is not a function. It fails the vertical line test. This input-output table, each x value is represented only once, so this is a function. Okay? Each x value, I shouldn't say x value, it's called an input. Each input has one output. No repeated inputs. Okay. Now for this table, you'll notice here 2 ones with different values that they're related to. So this is not a function. The value 1, x equals 1, has 2 different y values. It's repeated. The x value is repeated with 2 different outputs, right? Each input can only have one output. So that is how we justify a function, not a function. Let's look at equations. How do we know if I give you an equation, how would I know if it's a function or not a function? So we all know that the equation x squared plus y squared equals 1 makes a circle of radius 1. So if this is my axis, this is a circle here, centered at 0. This is xy. This is 1, -1, 1, -1. So this, we know, does not pass the vertical line test. So this is not a function. But how could I know if I didn't know how to graph it? And the key to this is solve for y. Okay, let's try solving this for y. When I solve this for y, I move the x squared to the other side, so I have y squared equals 1 minus x squared. Then, to free the y from the squared, I have to take the square root. Don't forget that when you take the square root, when you introduce a square root, the answer could either be positive or negative. And that's the key, is I could write it this way, or I could write positive negative y equals the square root of 1 minus x squared. Right? Those are the same thing. Now, is my x value repeated? And the answer is yes. When I input here or here, what I get out is two different values for y, a positive value for y and a negative value for y. All right, let's look at another example. So y equals x squared, right? This is already solved for y. When I put in an x, I get out a value. Right? By the way, the graph looks a little bit like this. All right, it's always growing. It gets less steep as it grows, but that's the graph of y equals x squared. Right? That is a function. All right, so that one is a function. Every x has only one y. Yes, x and negative x could share a value, but notice this starts at 0, so it doesn't include any of the negative x values. Now, the equation x equals y squared, not a function. All right. The equation x equals the absolute value of y is also not a function. That's because we need a plus or a minus to get rid of the absolute value. However, y equals absolute value of x. It is a function. It's already solved for y. There's no pluses or minuses, so I'm safe. All right. So that's how to use an equation to solve. There's one last thing I want to talk about when it comes to functions, and that is a special type of function. So we have relationships. And those are classified either to function or not a function. Okay, both can be graphed, but only this one passes the vertical line test. Once a function passes the vertical line test, there's a special type of function called a 1-to-1 function, or not a 1-to-1 function. So I write 1-to-1 like this sometimes because I'm a mathematician and I'm lazy. So what is a 1-to-1 function? And a 1-to-1 function is a function. It's a function with every input having only one output. Okay, so it's a function this way. No repeating. But a 1-to-1 function is also a function this way too. So, one of our examples from earlier was this middle one, this mapping diagram, and every input has an output. We said it is a function. This one is not 1-to-1. And that's because I can't reverse the arrows. If I reverse the arrow, the 4 has two different values that would be outputs then. Okay, so the 4 would be mapped to a 2, and the 4 would also be mapped to a 3. So it's not one-to-one. It is a function, but it is not a one-to-one function. All right, so that's what a one-to-one function is. How can I tell graphically? So the key to this one is looking at the graph and being able to see whether or not a function is one-to-one. So every x has one y, but every y has one x. Let's start with a simple example, y equals x. That is indeed a one-to-one function, and it's a line that intercepts at 0, 0, the origin, slope of 1. So this is a one-to-one function. It passes the vertical line test. Also, every 1x has only one y, and every one y value only has one x value. It's never repeated, right? Y equals x squared is a function, right? When I graph it, it looks sort of like this. This is a sketch of the graph, right? And what you see is, yes, it passes this vertical line test. Every x only has one y. However, each y has two x's. It's a function, but it's not one-to-one. Okay? And here's the key. The key is what's called the horizontal line test. One-to-one functions will pass the horizontal line test. This one fails the horizontal line test. When I draw a horizontal line in, it will pass through 2 times. All right, it passes the vertical line test. It's a function, does not pass the horizontal. This graph does pass the horizontal line test. A graph like y equals 1 over x, that one's a weird one. We're going to learn the name for all of these functions, and we're going to memorize their pictures, but this one, it gets really, really close to the axes, but never ever touches them. So this is the x and the y axis. Okay, it gets really, really close. This actually is a function. It actually does pass the vertical line test because these two never ever go completely vertical. They get really, really close to 0, but never pass it, just get microscopically close, and the slope becomes really, 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 really big, but it never goes undefined, so it's never vertical. So this is a function. Okay, because it passes the vertical line test, and it is one-to-one as well because it passes the horizontal line test. All right, so that's sort of the basics of relations and functions, and tomorrow we'll talk a little bit more about function and function notation.